What's up, everybody? Mr. Smith here. Before we dive into the new video today, let's start with a joke. So here's a joke for today. What happens when a frog parks their car illegally? They get towed. Yeah, that's just good humor right there. I know you're enjoying that. So let's dive into this new video today. We're actually starting a new unit. This week we're switching away from exponential equations and we're starting to talk about polynomials. All right, so let's talk about these things. First, let's think about what a monomial is. Okay, monomial is a strange word. All it means is just one thing. By one thing, I mean one number. I mean a number and a variable being multiplied together, or a number and a couple different variables being multiplied together. All of those things are considered one thing because they're all different pieces that are being smashed together by multiplication. Okay, so I know this guy looks like a bunch of different things, but it's still just one thing because they're all getting smushed together. All right. You can also think of the things as terms. We're going to use that phrase as well, terms. Okay. Then you can build up to have a polynomial, which is what we're talking about. Polynomial is just a big word that means multiple things or terms. So I'm taking a bunch of different monomials and putting them together by adding and subtracting. So I have 2x plus 1. That's two monomials put together. 3x squared minus 3. Two monomials. This is three monomials that I've put together. Okay? These are all polynomials. They're just a bunch of chunks, a bunch of things, a bunch of terms that I'm putting together by adding and subtracting. You can even be more specific when you're talking about polynomials. It could either be a binomial, which think about the prefix bi, that means two terms. So anything that has two terms in it, 5x plus 3, that's two individual terms. I could even be more specific and call that a binomial. In the same way, you could also have a trinomial, which makes sense. The prefix tri means three, so this is three terms put together by addition. I call that a trinomial. All right, so now we've got some vocab down. If you print out the note sheet, just so you know, I'm skipping this first part of the note sheet in case you're following along. All right, let's jump down here to parts of a polynomial. So remember, polynomial is just multiple things. They're all put together. Okay. There are a couple different pieces of a polynomial that we need to talk about. The first is the leading coefficient. That would be this guy right here. That is the leading coefficient. Remember, coefficient is just a number in front of a variable. Okay, the leading coefficient is just the first number. The very first number that's in front of everything. Okay, it's not an exponent, it's a coefficient, so it's the very first number. That can, in fact, be the number 1. So if you have a polynomial that looks like this, x squared plus 1, there's an imaginary x in front, there's an imaginary 1 in front of that, right? So the leading coefficient would be 1 in that case. Let's think about the degree. The degree is this piece right here. Degree. The degree is just the largest power that you have, or the biggest exponent, however you want to think about it. Biggest exponent, largest power. Okay, so in this case, this is a third degree, or degree 3 polynomial, because the biggest exponent I see is a 3. The constant term is this very last piece. Constant term, the 12 in this case. The constant term is the number without a variable, because it is not changing, it is constant. That 12 is not going to change at all. Even if I plug in something weird for x, 12 is just going to be 12. Okay? So those are the three different things we need to understand about a polynomial. Let's talk about standard form of a polynomial. Okay? Polynomial A right here is written in standard form. Polynomial B is not. All right? So let's just think about how they're different. Well, one difference that I see is that polynomial A, the exponents of each of these terms, remember the terms are just the different pieces, The exponents are in decreasing order. I go from 3, from 2, remember there's an imaginary 1 right there, and then 3 doesn't have an exponent. Whereas these exponents are not in decreasing order. In fact, they're not really in any logical order. It's 2, 3, 1. They're not increasing. They're not decreasing. They're out of sync. All right. So to be in standard form, polynomial is written in standard form when the powers of the terms decrease from left to right. They have to get smaller. That means that the degree has to be in front. The biggest power has to be out in front. Okay? So let's think about one example of this. It says write each polynomial below in standard form, then identify the degree, leading coefficient, and classify it as one of these three things: monomial, binomial, trinomial. Let's just do this first example together. Well, first I got to think, is this thing in standard form? Remember, standard form means the biggest exponent needs to be in front, and then it decreases from there. Well, clearly right now it's not in standard form. The x squared needs to be in front. X squared needs to be in front. Okay? So I'm just going to rewrite it. 5x squared needs to go in front. And then my next smallest degree, or my next smallest power, needs to come after that. Well, that would be this. The x would just to a power of 1. So it's minus x, and then 4 is at the very end. My constant term is at the very end. Now this is in standard form. The degree is 2, because that's the biggest power that I see. The leading coefficient, the number that's in front of everything once it's in standard form, is 5. Okay, and then if I want to classify it as either a monomial, binomial, trinomial, well, it has 1, 2, 3 terms, so it's a trinomial. All right, so there's an example dealing with all the different pieces of a polynomial and writing it in standard form. Let's move on now to doing operations with polynomials. This is one of the main things that we need to talk about. Today we're just going to talk about adding and subtracting polynomials. So let's say I have two polynomials and I'm asked to find the sum. Remember, sum just means adding. All I'm going to do here is, since I'm adding, I am going to add the like terms. I'm going to add the like terms in my polynomials. Okay? So I have to be really cautious. I am adding, so I can't lose track of that. All right? So here's how I'm going to do this. I'm just going to do it one like term at a time. So I have x cubed over here. I'm going to take that 2x cubed and add it. Sorry guys, I have to let my dog out really quick. She's being kind of annoying. Alright, sorry about that. So I'm going to take the 2x cubed in this first polynomial, and I'm going to add it with whatever x cubed is in this second polynomial. And I have to do it, I have to think about like terms. Since I'm dealing with an x cubed over here, I have to add that with the x cubed term over here, which is right here. It's just 1x cubed. So 2x cubed plus 1x cubed gets me 3x cubed. Okay. Let's do a different term now. Minus 5x squared. I am going to add that to the x squared term in my second polynomial, which is right here, plus 2x squared. Negative 5x squared plus 2x squared, that's negative 5 plus 2. That would get me negative 3x squared. Okay. Now let's do the next term. It's just an x. So I have to look in my second polynomial and see, do I even have a single x term? Turns out that I don't. I don't have a single x in this second polynomial. So I can think about it like this. I'm doing x over here plus nothing, or no x, over here. It'll look like this. X plus nothing, which is just 0, is still just x. Okay. All right. And now I still have one term in my second polynomial that I haven't accounted for yet. It's the constant term, negative 1. I haven't done anything with that yet. There was no constant term in this polynomial, but there is a constant term in this polynomial. So you can think about it like this. Nothing in this first polynomial, 0, plus negative 1, in this second polynomial. 0 plus -1 would get me -1. Okay? So now I have all of my pieces, all of my terms, my like terms have been added together. So now I'm just going to take each piece and write it all as one polynomial in standard form, meaning the exponents are decreasing. So 3x squared will be first, and then I have minus, oops, sorry, that's 3x cubed, not 3x squared. 3x cubed is first, and then I have minus 3x squared plus 1x, or just x, minus 1. Okay, and this is my final answer. All right, so all I'm doing is adding the like terms. All right, let's do an example of subtracting a polynomial. So everything is the same except now instead of adding, we are subtracting. We are subtracting like terms. Okay, so we have to be careful. We're subtracting these things, so it's helpful to go one piece at a time, just like we did before. I'm going to take my first term, 4x squared minus whatever x squared term is over here. That's 3x squared. I'm going to figure out what that is. 4x squared minus 3x squared is just 1x squared. Now I'll do my next term. I have negative 3x minus negative x. Okay, that's my x term in the second equation. Notice how I'm still thinking of this as a negative x, since there's that negative sign in front of it. I can't just forget about that, okay? This is a negative x. So it's negative 3x minus a negative x. So that's actually a double negative right there. We have to be really careful when we're subtracting. We can't lose track of our negative signs. This is negative 3x minus negative x, which again, if we have a double negative, that's like adding. So that's negative 3x plus x. That would get me negative 2x. Okay, so you have to be cautious. Don't get ahead of yourself and lose track of a negative sign. Let's do our last term here. I have 5 minus negative 8. So again, I can't lose track of this negative sign. It's 5 minus negative 8, not 5 minus 8. 5 minus negative 8 is 5 plus 8, which is 13. Okay? So I've done all my terms. I'm not missing anything. I haven't left any term out. Okay, so now I can just go ahead and collect all of my new terms and put them all together into one polynomial. It's going to be x squared minus 2x plus 13. And that's my final answer. Okay, so if you're following along with me on the note sheet, notice that I crossed out the horizontal format. We're just not going to look at that for sake of time. I hope this was helpful. If you have questions, feel free to email me, hop into office hours. Let me know if I can help you guys out in any way, shape, or form. Appreciate you watching this video. See you soon.